Hello. Hope we are all ready for an introduction part. My name is Dingani. I'm going to take you through this revision. I hope everyone is getting me. Are you people getting me?
Yes, we are.
Okay, thank you very much, Mercy. Thank you very much, Deborah.
Thank you.
And please always turn off your mic just after responding. I'm sure, I think the guy who is behind everything that's happening here has already shared with you a few documents. So we are going to cover a bit of functions. We're doing mathematics, right? You're here for math. I'll take silence as a yes. You're going to pardon my handwriting on the whiteboard because it's not so good. I'm just using a mouse to write, and I don't think I'm really good at that, but I hope you're going to follow. I sent a couple of documents that we are going to follow. One that says relations, and we are going to use Math 1100 lecture notes as well. We're going to be referring to them. Then I'll just give out a few points, and we'll try to tackle a few questions from a tutorial sheet. I'm sure you all have your tutorial sheet. That should be tutorial sheet 2. Math 1100 as well, I'm sure. Let me just try to open my tutorial sheet as well, but I'll be sharing the whiteboard. If I am too fast at any point, please just raise a hand. There's a hand gesture that you can use to raise your hand, and let me know. I'm sure I'll see it through and attend to your queries. Let me just open the tutorial sheet as we start. Okay. Yes. Okay, I think we can start. Just share a whiteboard. Okay, before I share a whiteboard, let me just Are you able to see the screen I'm sharing right now?
Yes.
Okay, thank you very much. Then I'll take that as it is happening to everyone. So we're going to look at functions, but first, before we look at functions, we're going to get a few joint points on what relations are. Also wants to that. So a relation.
Yes. Math.
Hello. Please turn off your microphones. So what are relations? Relations, basically, they can be defined as mapping that exists between two sets. Let's say you have a set 1 here, then you have another set here. So the relation is that rule which exists in between these two sets that says what happens for you to get from here to go to this part of a set. So you would always have two sets for you to get a relation. Say this is set A, and this other set is set B. So you'd have elements in this set that are being mapped onto other elements in set B. So the relationship that exists between this mapping is what we call a relation. So for a formal definition of a relation, it will be defined as, we say, let X and Y be two sets, in this case, which were my A and B, these two sets. Then a binary relation, or simply a relation from X to Y, is a subset X cross Y, that is a real number, that's R, is a relation from X to Y. If it is a set of all ordered pairs, so in this case, the relation that exists in, let's just try to add a few elements. Let's say A naught, let's say A1, then we have B naught and B1. So a relation would be any pair, any ordered pair that is pairing elements of A and elements of B. So we have an example here. One of the examples that is showing us. Say, hello maps. I can see you're annotating on the screen. Thank you for trying that out, but I think for now, let's allow me to annotate. Thank you. Okay, so in this example, we were saying if A is equal to that set and B is equal to that set, and says show the relation R that maps A to B. So in this case, we want to see what relation is mapping set A, which is this guy here, with those elements, being mapped onto set B, which is this guy there, with those elements. So let's say we have this set A is 1, also have 3, also have 4 and 6. Then we have B with elements 1, 9, 16, and 36. Please pardon my 36 there. It doesn't look like a 3, but I'm sure you can see from there. So this relation that maps A onto B is every ordered pair. So in this case, the relation that maps A into B, we have A being mapped onto straight with 1, 3 mapping onto 9, and we have these other 4 mapping onto 16 with R there as a relation. So this relation, if we were to define it in terms of a formula, we would say that A, which is let A be a member of set A, and B be a member of set B. Then R would be this relation that A, or rather let's say B, this relation R is B is equal to A to the power 2. I hope that is clear. And from here, these were the sets, the elements paired in this ordered manner. We have 1 being paired with 1, 3 being paired with 3, 4 with, or 3 being paired with 9 rather, 4 and 16, and 6 and 36. So in this case, a couple of getaway points here that we need to get is that with every relation, there has to be 2 sets. One set, which is a primary set, in this case our A set, which will contain elements that would cause what? The domain. Like in this case, I gave domain, it is bold, and this is a kind of simple definition that would help you remember such things. So a domain are members of a primary set that exist. So in this case, the domain, if we are told to list the domain, we would list all elements in A for this particular example. If we were told to list the codomain or the range or the image, this second set B would be called the codomain, the range, or the image. And it only exists because of the existence of A. Are we together? Silence means it's clear.
Yes.
The line is bad. Okay, let me just try to clear this part so that we can move on. Do we have any questions up to this point? So now we go further into the gist of this very topic. Sure, we are interested in function. So what is a function basically? So a function is a mathematical expression that governs a well-defined relationship between two sets, set A and B, where set A contains the independent variable and B is the dependent variable. So for a formal definition of a set, what we would want is to have, say we have two sets, say X and Y, are those two sets. Then the function f, from which X, for which X into Y is a rule that assigns each element X, a member of that set X, to a particular element. Is that one with their mic on? Please turn off your mics. Then a function f from X into Y is a rule that assigns each element X, a member of the set X, to a particular element Y, a member of Y. The notation for function is that notation there. This is read as maps X into Y. Then you come to some part that calls itself the domain. The domain of a real function are all values of the independent variable that makes the values of the dependent variable real, while the range are all real values of the dependent variables due to the existing domain. Like in this case. In this case, we have set X and set Y. A function is anything that is shown as this, that is noted as this. Say a function f mapping X onto Y. So in this case, let's say we have this set here and that set there. Let's use the same thing there we had. Say we had 1 here, 3, 4, and what number was that? 6. So if we say there exists a function between these two sets, so f is here. Since f is mapping every other element in X onto Y, so we would say that since X is a member of this guy, so X, this member, and Y, which is also a member of Y. So I want to come up with a function that maps X onto Y. So this function would be, so since because if we can see here, we have 1 being mapped onto 1, 3 being mapped onto 9, 4 being mapped onto 16, and 6 being mapped onto 36. If you take a critical look at this, So sorry for that disturbance. So what we have here, want to get this relationship that maps x onto y as a function. So in this case, if you can see, for us to get every other element in y, we are just squaring what we have as in x. So y would be equals to x squared. In this case, y is just a function, so this would be written as f, which is just a function of x, is equals to x squared. Squared there. Squared. I'm coming, just give me a minute as you digest that. When I come, we are going to look at the tutorial sheet and a couple of examples. Just give me a minute, let me just try to attend to something.
Yeah, mama ni nani? Switch off your mic. Nabonga ni mute your mic.
I'm sorry for that. I just had to attend to something, but we can continue. Okay. So here we've just defined what a function is. And I'm sure we defined also what a domain is and what a range is. This can be found here. This is telling us about the domain and the range. So let's try to look at an example for us finding the domain and the range of certain functions when we're given functions. I got this from your tutorial sheet. So example there says find the domain of each of the following functions. A, f of x is equals to the cube root of whole x minus 10. So in order for us to get the domain of these functions, let's try to look back into the definition for a domain. Domain of a real function. Domain of the real function are all values of the independent variable. What is an independent variable? An independent variable is a variable that just exists depending on nothing but itself. In this case, the independent variable is x, and the dependent variable is f of x. Are we clear on that one?
Yes.
Thank you for the response there, sir. So in order for us to get this domain, so the catchphrase in this statement is real. The domain of a real function are all values of the independent variable. That makes the values of the dependent variable real. These that I've underlined are our catchphrases that are going to help us define domain for each of these functions. So if this function, given this function, want to find the domain, f of x is equals to the cube root of x minus 10. What values of x do we need to be taking each time so that f of x is always real? That's the other term they can use to ask us for a domain in this case. If we understand it that way, then it's going to be easier for us to get the domain of each and every function that we have given. So let's get this very function. So for us to find at which point is this function real, we also have to check what is in the cube root. So this is going to be our main interest. What is in here? So since we know that we can get cube roots of, what is the cube root of -2?
It's not real.
It's not real.
Yes.
Good
It's
try.
a complex number.
Actually, the cube root of -2 is negative root of cube root of 2. It actually exists. There exists a number. Say this is cube root. This is a 3 there, -1. What do we get when we get the cube root of -1?
-i.
Sorry?
-i.
I can't get you. Please speak up a little bit louder.
I think it's negative. What I know basically is that you're going to get complex numbers.
Okay,
I'm not sure. Maybe it's -1.
Maybe it's -1. -1, it is correct. So the next time, just drop the maybe and say -1. The cube root of a negative number does exist because we can multiply -1 3 times and get -1, won't we?
Yeah.
Exactly. But the cube root, the square root of -1 is going to be complex. Right?
Yeah.
So it means for this function, we do not care whatever is in this argument. This function is always going to be real. Are we together?
Yes.
Hello?
Yes.
Okay. So,
Yes, sir.
so since we want to get the domain for this part, if we put -11 here, -11 minus 10 is going to give us negative what? 22. The cube root of -22 does exist. Are we together? Your
Yes.
mics, please.
Question.
Somebody has a question? I'm sorry, I'm going to mute everyone. Who has a question?
It's me, sir.
Yes, the emoji guy.
All right. So the cube when you're dealing with negative numbers, so when you have a cube root of a negative number, it does exist. It doesn't mean that you're going to get complex numbers when you're dealing with cube roots.
Yes, when you're dealing with cube roots, every time when you have this power here, odd, it doesn't matter what you have in this case as an argument.
Okay.
Yes, the cube root of -8 is going to be what? -2. The cube root of 8 is going to be 2.
But when you've got even numbers on the square root,
when you have
then
even numbers here, only positive are going to be allowed in here. When you get negative, it's going to be a complex.
Okay, thank you.
Yes, you're going to see that as for our case in example B. So for example A, since we all agree in here, in this meeting and everywhere else mathematically, that a cube root of a negative number is going to give us a real number. The cube root of a real number, whether negative or positive, it's going to give us a real number. In other words, we can say that the cube root is binary on all real numbers. So in this case, the domain would be all values of x ranging from -infinity up to infinity, as stated here. We have answered part A. Is it clear? So that we move on to part B.
Yes.
Yes.
Now we come to part B. Says find the domain of that function. Since this function, we are looking at the fourth root of whatever is in here. It's like finding the square root twice, isn't it? F of x is equals to the fourth root of 1 minus x. This can also be written as square root of the square root of 1 minus x. Since this is a real function, so we want every time we use any value of x, this should be a function as well. So we are just going to consider 1 minus x squared. Do we have the square root of a negative number? That is real.
Complex. It's a complex number.
Exactly.
It's
Thank you
not
very
real.
much. So what we want is that this part of the argument should always be greater or equal to what? 0. So this part here, the greater or equal, means that we are only dealing with numbers. Let me just try to draw like a number line here. We have -1 there. We have 0. Then we have a 2. This greater or equal is telling us that we are here at 0, standing at 0. And this part should only contain numbers that are greater or equal to, or greater or equal to what? 0. Where are numbers greater or equal to 0? This part. So we're only dealing with the positive end of the number line. So in this case, we try to solve for x in this case. When we solve for x, it's either we get x to the other side or we get 1 to the other side and then divide by a negative sign. But the easiest would be just get this x and throw it to the other side so that you have 1 is greater or equal to x. Then, since you have this, we are always used to seeing stuff like x and number there. We have a 1. But what sign would we put there? Since we have flipped everything, even the sign has to be flipped. So that x is going to be all values of x that are less than 1. So if you look at this, if we are going to sketch this domain, let me just clear this. This was just an example. Different color as well for this one. So we want to sketch the domain of x. The domain of x, want to sketch the domain of x. Let's get a number line. There, 1 there, 0, 26. These are just arbitrary numbers. Don't mind there. So it says x has to be less or equal to what? 1. So at 1 here, and since we have an equal to, this point has to be shaded. Then it says x has to be less. Where are numbers that are less than -1? Numbers all the way going this side to -infinity. So x is going to take all numbers that are less than 1, which is starting from 0.99999 all the way down to -infinity. So this is going to be our domain. In this case, I've written it compact as a domain of f is x such that x is a member of real numbers, but x should be what? Less or equal to 1. Are we together?
Yes, sir.
Oh, thank you. Wonderful. This one is active. Okay, now we move on to this other part. This other part, in as much as it looks complex, it is as simple as doing the same things we have been doing. So what we have is f of x is equals to the root of that over that, since we have x in the denominator and x on the numerator. So the domain has to be taken into consideration that x on the denominator part should always be real and x on the numerator should always be real. But since this is a polynomial, this is going to be real for all x, but since this is a fraction, p over q, what happens when q is equals to 0?
It's undefined.
Very good, it's undefined. In other words, we are saying it is not real. So in this case, we want to exclude the fact that this denominator q, in this case, let's assume our q is equals to x minus 2. So we want q not to be what? Equal to 0, isn't it?
Yes.
Wonderful. So in this case, for us to find the domain, it's going to be all real numbers except at certain points, and x has to start from somewhere. So we'll look at the numerator part. The numerator part, we have stuff in the square root. So this part, we want this to always be what? This part inside here, x plus 1 should always be greater or equal to what? 0. So in this case, when we solve for x, we have x should be greater or equal to -1. But this is not everything. This is not everything. This is not everything. We also have x minus 2, which is on the denominator. And a fraction, we want to make it such a kind that every time we have a value of x, this is going to be defined and it should never be 0. So the other part is going to be x minus 2 should never be equal to 0. At no point should this be equal to 0, or else this is going to be undefined. The function is not going to be real and your domain will be invalid. So for us to get a valid domain, we say it should not be equal to 0 and solve for x so that we know what values of x should we exclude from the real numbers. So get the 2 to the other side. So x should never be equal to 2. So x has to be greater or equal to -1, but x should not be equal to 2. In this case, if I were to sketch this, if I were to sketch these guys, let me draw the number there. We have -1 there, 0. Put 2 there, and 30 there. So it says x is greater or equal to -1. So x is greater or equal to -1. It's all values going this side. But then it also further says that x should not be equal to 2. So let's put it a open box here, open dot. So this is going to be a sketch of our domain with a discontinuity at this point. This is a discontinuity. It has a jump at this value. Hence, our domain will be domain of f is x, such that x is a member of real numbers. X should be greater or equal to -1, and x should never be equal to 2. That would be our domain. And for the D part, I thought you guys had this paper sent to you before coming to join the meeting, so I thought you'd do this part. But did any of you receive this paper?
Nope.
Okay. Okay. That leaves us with this part, example D. Example D. Who is going to run us through example D, if that has been understood? People are quiet. People don't want to solve.
Can I try?
Yes, you can try. Emoji guy.
I'm just trying. I'm not sure, but
Yeah, trying
X
is
should,
where we learn from.
X should be greater than 0.
X should be greater than 0. Okay, wonderful.
Yes.
Why should X be greater than 0?
Because you don't want a negative value in the square root, and you don't want anything to be 0 in the denominator.
Oh, wonderful. The emoji guy has an idea. But what if X is equals to 0?
Then you're going. Then the fraction is going to be undefined.
Oh, wonderful. That's great. So whatever we do, since X is in the denominator and X is also in the square root, we don't want X to be less than 0. But still, since it's in the denominator, we don't want X to be equal to 0. So in this case, X is going to be all real numbers except X will never be what? Oh, no, not never, but greater or something like that. X should be greater than 0 for this guy. Is everything clear?
Yes, yes.
What about the others? Are we okay?
Yes,
No,
sir.
sir.
Okay, there's a no.
Usually
That's
that.
wonderful there. Who is
Yeah.
giving us a no?
Jeff, sir.
Oh, yes, Jeff. Where's the problem?
Okay, sir. I didn't get the concept. Can you kindly repeat that? Where you actually drew the number line, where you open the dot,
Here,
where there is 2. Yes.
where I opened the dots. Okay,
Yes. Yes. I'm behind.
okay. Don't worry, Jeff. We are not leaving anyone behind from here.
Yes, sir.
Just try to clear the board. And our time is just 17:54. And I'm sure after this, I'm going to take concerns if you have concerns in your tutorial sheet, especially tutorial sheet 2 for now. So if you have concerns in the tutorial sheet 2, we can just quickly check them out so that you can solve 1 or 2 questions from there in the next, let's say in the next 20 minutes, since we started a bit late. Okay. In the meantime, let us attend to Jeffrey's query. So Jeffrey, what we are trying to do is we want to find the domain of this guy, C.
Okay.
Okay. So I'll ask you to read this part, Jeff.
So it says where the part for the domain
Yes, the part which says the domain of the real function
are values of the independent variables that make the values of the dependent variables real. While the range are all real values of the dependent variables due to the domain.
due to the domain. Okay. So what we've actually established right now, Maliseni, I've seen your hand up. I'll attend to you. Just a moment. So what we've just taken out from this is that this function has to be real due to the domain. So this domain is what is the independent variable, and it should make the dependent variable real as well. So f of x, x is the dependent variable in this case, or x is the independent variable, pardon me. Then f of x is the dependent variable. So the independent variable x, what values of x should x be taking such that f of x is always defined? So now, if we have an expression, say p over q, what happens when q is equals to 0, Jeff? In this case,
When q is equals to 0,
yes,
the gentleman said something like, is it undefined?
yes, it is undefined, but what do you say yourself?
Yes. I think I'm agreeing. Yeah, it's undefined.
Oh, yeah, agreeing. Okay, very good. Just in case you're out of curiosity, get a calculator one day and say 22 divided by 0 and see what math is, what answer it's going to give you. Yeah. So since we do not want this guy to be equal to 0 at every point, because when it is undefined, this function will also be undefined and it won't be real. So in this case, let's assume our q is equals to x minus 2. This guy, we don't want it to be 0. So we are saying, we're going to say not equal to what? 0. So that when we solve, this 2 goes to the other side, we'll have positive 2, right?
Okay.
Saying that x should never be what?
0.
2.
Oh, 2, sorry.
Yeah. So this is part of the domain, but we also have this guy. So this part of the domain is telling us we can pick out any values, but not x is equals to 2. In other words, this was God telling Adam and Eve, you can eat of every fruit, but do not eat from the one that is in the middle. The one that is in the middle is 2 in this case.
Okay, sir.
All right.
That's
Then,
a good example.
for this domain, for this part, the numerator, the p part, we know that everything that is in a square root, it has to be greater or equal to what? 0. For this to be defined, x plus 1 has to be greater or equal to what? 0. Let's solve for x in this case. We throw the 1 to the other side so that we have -1. So in this case, what is this guy telling us? He's telling us that x is going to be all real numbers that are greater than -1. If we pick out any number, 78, 93, -0.5, -0.009, this part of this function is going to be defined. So when I drew the number line there, let me just try to scroll down, maybe I can get a few more empty space. When I drew the number line, come on. So we have our number line there. Then we have our -1. We have our 0. We have our 1 there. We have our 2. We have our 30 here. So we have a couple of numbers in between 2 and 30, but ignore them.
Yes.
So let's start first trying to map this on the number line. We draw this on the number line. We are at what? 1. Since it's greater or equal to 1 is also part of the solution, we shade the inner part of this Kawasaki. Then it says x is greater or equal to -1. So all numbers that are greater than -1 are which side?
This side, the positive side.
Thank you. The positive side.
Yes, sir.
But God told Adam and Eve not to what?
It the fruit in the middle.
Exactly. And that fruit in the middle was what? Yes. So this circle here is telling us that 2 is not part of the solution in this case. That is why I had that circle. Is it clear, Mr. Jeff?
Okay, thank you, sir. It's clear now. Thank you.
Wonderful. Malisheni, was it Malisheni who had her hand up, his or her hand up? She's out of the meeting, I can see. Is there anything else?
Nope. I think I'm clear. I'm okay.
You're clear.
Yes, sir.
Everyone else, Veronica, are you okay?
Yes, sir.
Okay, wonderful.
So we okay.
Yeah, okay, okay. Before we leave, allow me to touch a few questions from the tutorial sheet. Let me just stop this sharing and start another share where I can share, I think, the tutorial sheet so that you can see if we can tackle 1 or 2 questions from there. Is that okay?
Yes.
Yes, sir.
Yeah. And
Yes, please.
okay, we have the message from the chat. Oh, it says chase, bro. Let me just try to, oh, did I even open the challenge? Let me just open.
Yes.
Exactly. Okay, thank you. Let me just try to share this the tutorial sheet. Actually, This is just for you guys to get to know what you need to do. So if you do not ask questions, you are going to miss out on certain points. This is where you need to ask every question that has been bothering you, so to say. If you have a problem on certain topics, this is where you bring it up. So that at least as you head towards your exams, you are comfortable. Even as those seniors are singing fresh hour, you know that you are confident.
So just to disturb you a little bit. So when are we going to do trigonometry?
Trigonometry. I'm not so sure, but it's going to be very soon because we have to finish, we have to cover so much that you have enough to stand with in your exams.
All right, all right.
Yes.
Thank you.
You have a problem with trigonometry?
Yeah, very much.
It's going to be made simple.
All right.
Thank you, sir. Thank you.
And calculus as well, sir. Should also
Don't
add that.
worry, don't worry. You are going to be the disciples of mathematics after these tutorials. Okay, I'm sure my tutorial sheet is ready. Just maximize and start the sharing. Okay, right now I'm going to share a tutorial sheet. That was tutorial sheet 2 for those, I think, doing math 1100. Share screen. Which one am I sharing? I'm sharing the tutorial sheet. Okay. Is everyone seeing the tutorial sheet I'm sharing?
Yes.
No. Oh, yes.
Okay,
Yes, sir.
wonderful. It has loaded. That is wonderful. So I'll concentrate much on the let's say question starting from question 13 going down up to, I don't know, whichever question is there, ending up to question number 20. Oh, lucky me, this is going to be very short. Could you even make it any longer? Okay. Are you guys having any problems anywhere in the tutorial sheet that we need to tackle together before I start doing my own things here? Hello?
Personally for me,
Personally, for you, this is the same point.
yeah. No, not simple, but no.
Okay, it's okay. I was just joking. Let's just try to solve one or two from here. Okay, let's try to look at question 13. Question 13 says, which of the following sets of ordered pairs represents functions? So, if you remember the definition of a function I gave, let me just go and read it. The definition of a function I gave. You guys are still seeing the tutorial sheets?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. For a formal definition of a function I gave, I read to you that formal definition, let x and y be two sets. Then a function f from x into y is a rule that assigns each element x, a member of x, that set, to particular element y. Catch that phrase there, particular element. So in this case, what I'm saying is that a function has to have one element mapping straight to only one element. What do we call that condition? that the function is 1 to what? One to one, people. You're responding, tell us. So for an ordered pair to be classified as a function, it has to be 1 to 1. Each member of the domain should have only one member of the codomain. So if you have, let's say, let me just wait. Somebody has their mic on, please turn the mic off. I'm getting a feedback here. Thank you. You guys are sweet. So if you have, let's say you have this element, 1, 2, and that's a 3. Then we have A, B, C, and D. This, say this is X, and this is Y. This is only going to be considered a function if only one element is being mapped onto only one element. It has to be a 1 to 1, as in this to that, this to that, sorry, and this to that. This is a 1 to 1. But in a case where we have this one as well is being mapped onto this other one, and this also one is being mapped onto this other one, with these two being mapped onto that. This is not a function. A function has to have one member in X mapping to a particular member in Y. So in this case, let us look at A. Just clear this. So much space to write in this case. Let us look at A. A, we have 1. So these are going to be for the set A. Let's say set A for the domain. This guy. So for the domain, we have 1, we have 3, and 7 being mapped onto the range set is the ranger, these guys. We have 4, and there's also another 4. There's no need for us to repeat that it's a 4. So we have this being mapped
Hapa so time
onto,
so ni maklasi hapa. So hapa 18 kuli maklasi 19 20.
mapped onto that. Then 3 is also being mapped onto 4. Then we have 7 being mapped onto 3. Since we have 2 elements being mapped onto an element here, this one is not going to be considered as a function in this case, because the definition for a function says that it's a rule that assigns each element X to a particular element. It has to be a 1 to 1. But in this case, this cannot be considered as a function because it has certain other elements are all mapping onto one element. So it can't be written as a function, say f of x is equals to something. We cannot have one value of x giving us 2 values of x, can we? Hello?
No, we can't.
Okay. So we would actually do the same for this guy. Even this guy, if you look at this, you have 1, 1 here, and 2. 1 is being mapped onto one element is being mapped onto 2 different numbers. That cannot also be the case. This B is not going to be a function, but would consider this other guy to be a function at some point. So for you to get a function, what you just need to know is that the function has to be one-on-one. It has to be a set, one and only one element in X has to be mapped onto Y. So in other words, a function has to be a one-on-one. Is that clear? I'll take silence as it is clear.
It's clear.
Yes, it is.
Okay, wonderful. Then let's try to see if we can solve another one. We have a couple of more minutes since we started at 17:17. If we take an hour, we are supposed to end at 18:18. Just try to see if we can solve something that looks nice. Let's try to look at this guy. Let's look at 15. Given that f of t is equals to that, find and simplify each of the following. This guy, this is f of t. So when you have f of t is equals to a certain function, so f is defined by this function for every variable t. And when we have an expression with f of 3, in this case, they are just telling us to replace 3 at every point where there is t in that function. Is that okay?
Yes.
Okay. So that when we get this guy, we start A here.
No,
F,
it's not, sir.
sorry. Okay, it's not clear there.
Mhm.
When you have a function written as this, f of t, and you are being given this, where this 3 is, there was a what? A t, right? You have f of t is equals to the root of 25 minus t squared. Then they're asking you to simplify
Yes.
f of 3. So what this is actually telling you is that where there is a t in this f of t, replace it with 3. So in this case, we are going to
3.
replace with the 3 for a part. F of 3,
Okay.
this pardon my writing, is going to be equals to the root of 25 minus 3 squared. Since you guys don't use calculators, you have to be very good at math and you have to be quick. What is this? What is the x 3 to the power 2? That should be a 9.
9.
25 minus 9, that should be a 16, is it?
16. Yes.
16. What is the root of 16?
Plus or minus 4.
Oh, that's wonderful. I'm always looking for that plus or minus 4. You have an A in math.
Thank you.
You have a 5 here. B, it says f of 5. What is f of 5? For t, replace it with 5. 5 to the power 2. 5 to the power 2.
25.
Exactly 25
25.
there. 25 minus 25, that's a 0. The square root of the 0 is plus or minus 0 or just a 0.
Just a 0.
Oh, wonderful. You guys are good. Now we have this guy. It says f of x plus 5. What do we do in this case? In this case, we do the same things we've been doing. Yes, we replace f of t is equals to the root of 25 minus t squared. Where there is t, we put x plus 5. So this is going to be equals to the root of 25 minus, this is going to be x plus, oh, it's a plus 5 there. X plus 5. The whole lot of this is squared. Since they taught us to what is simplify, let us try to simplify this. So this is going to be 25 minus x squared minus 10x minus 25. So this 25 and that 25, they give us a 0. So in this case, what we have in the square root, we're just going to have negative x minus negative x squared rather. Negative x squared minus 10x. This is what we get for part C. Is it clear?
Yes.
Yes.
We are going to do the same thing for D. We're just going to replace T by what? 2x. So that in this case, when we replace f of 2x is going to be equals to the root of, we have 25, it's a minus here, 5 minus 2x. The whole root of this is what? Squared. So this is going to be the root of 25 minus 4x squared. Since you guys are very good at math, you need to show that you are very good at math so that you even get more marks. This is a difference of two squares. Write it as a difference of two squares. Simplify things for them so that they give you full marks. These are two x's. This is what you get when you replace t with 2x. Is that clear?
Yes.
Yes, it is.
Okay, wonderful. Then we're going to skip this part, 16. Since you guys are good with 15, you guys can do 16. Next time, if you have a problem, or the next time we meet, if you had problems with solving there, just say, me, I had problems there. We'll tackle them together.
So, sir, before you answer a quick one,
Okay?
looking at math, right? And
Yes.
the time that we have, don't you feel like maybe they're just okay? Let's say, are there any like specific topics where we are supposed to focus, where we're like, okay, these I must know, and then these you can add on? Is there anything like that?
For now, what I can tell you is that what you've actually covered in classes
Yes.
is actually everything that you've covered in class is very important and it's going to cover for your exams. I do not prepare your exams myself because I'm a student as well. But what I know is that whatever you've covered in class up to this point in math, it's very important. If you take a look at math 1100 or whatever math you're doing right now, it's introductory mathematics, something like that. And
Okay.
every concept that you learn is actually important. It's a concept that is built, like they're just building blocks of what mathematics actually is.
Okay, thank you.
So you're just laying a foundation. So whatever topic you've covered, you need to know it. You know it by heart, because certain things are like whatever we are just doing here is what you're going to be applying using when you're solving trigonometric equations or when you're solving quadratic equations. You need to apply these concepts.
Okay, thank you.
So question 17, it says find the domain and range of the following. This is very simple. It says f of x. F is this A. We have these. The first elements are what? Domain. These other elements, the second elements are for the range. You don't even need to write a mathematical expression to show that this is the domain and the range. Just put them in a set. If you want, you can put them in a set like that. If you want, you can just list them in a set like this with those curly brackets. I hope my brackets are curly. This is the part we covered. So even this guy, the domain of G is 10, 20, 30, 40, and 50. The range of G is -4, 1, 6, 9, and 13. You don't add, you don't subtract from these because they've been given as an ordered pair. Is that clear?
Yes.
Wonderful. So I'm sure we are going to end here for today.
Sir, I have a question before we end.
Okay, that was rude of me to almost leave without attending any of your questions. Yes, madam, please go ahead with your question.
Yes, sir, on question 13,
Okay,
part C,
but
did
see,
you say it's a function or not?
but see, let's look at it together. So we have 4, then we have 3. That is in the first set. Then in the next set, we have 3, 7, and 4. And then we have 4 being mapped onto 3, and 4 being mapped onto 4. Then we have 3. Oh, 4 is mapped onto 7, right? 4 mapped onto 3, 4 onto 7, and 3 onto 4. So what we have in this case is that we have x. X in this case is being mapped onto 2 elements in this guy. So since 4 has no unique value that is being mapped onto, that it's mapping onto, it's mapping on 2 elements. So this ordered pair cannot be considered a function because this has got 2 values. So this would
Alright.
not be considered a function. Is that clear, madam?
Yes, thank you.
You're welcome. Do we have any concerns anywhere before we end the meeting?
Excuse me, sir.
Yes?
Do you have tutorial sheet 3 for math 1120?
No, I just have this. You have a concern on tutorial sheet, on that same tutorial sheet?
Yes.
Can you read out the question?
Okay. It says find the inverse of the following functions defined by the following equations if the inverse exists. If the inverse does not exist for the largest possible domain, limit the domain so that the inverse will exist. In each case, give the domain and range of both the function and its inverse. So my question was how you'd limit the domain of a function.
How you limit the domain of a function. Do you
Yes.
remember that example?
Do you have to use the...
Okay, sorry. Please go ahead.
Yeah, I was thinking maybe like if you use a graph and then okay, like I think you can just explain. It's fine.
Actually, where you're heading is actually better that way. Okay. When they're asking you to limit the domain, it means they're telling you that at a certain point, that function would not exist. It won't be real. So you need to limit the domain. If you remember that example where we solved, I think it was this question.
Yes.
Yes. We limited the domain that x was never what? Was never 2. Even if we say that x was anything greater or equal to -1, but we limited the domain that it should never take a value of x is equals to 2. So actually when you're finding the inverse of a function, they will come at a point, because most of the times when you get inverses, you find that you have an inverse, the function, the way it looks, it may be a fraction. So it won't exist at certain points So that inverse won't exist at certain points, say when the denominator is equal to 0. So at that point, that's where you limit the domain. Is that clear?
Okay.
Yes.
Yes.
So it's actually asking you to actually find just the domain. So in finding the domain, you find that you're limiting out or excluding certain values that X should never take. It's just that
Okay,
we
so
are
it's
done.
just finding, sorry,
Yeah, okay, go ahead.
it's just finding the domain. You don't necessarily have to draw a graph and then find where you don't get 2 points for the same, like for the same line.
Okay. It would either be you solve manually, like we've been doing, like we did for this, or you actually draw a graph. When you actually draw a graph will show you exactly where that function is either continuous or discontinuous at any point, if you draw it correctly. But if you solve using those certain conditions, that this should never be 0, so we say x minus 2 should not be equal to 0. It's just going to give you specific points that should be excluded from your domain.
Okay.
Yes,
Thank you, sir.
you're welcome. Anything else? And that was a very good question. I'm actually not limited to solving math 1100.
I've got a suggestion.
Okay.
I've got a suggestion.
Please
Can we
suggest,
do
I'm
math
sure this
1120
is
next time we meet?
math 1120.
Can you do, yes, the tutorial sheet?
Okay. That's not a problem. Actually, I was just given this part of the tutorial sheet, but we actually have to cover every math that is being covered in first year.
All right, yeah, math 1120, the tutorial sheet on the same functions.
Okay, yes. So you put that up in the group where you got the link from, or if you were given the link in your inbox, tell the person who gave you the link that we need to do this tutorial sheet and give it to them.
That's Charles.
Yeah, I actually don't know his name. I was just assigned to take up this class, but you just refer back to the person who gave you the link that next time, please, we need to do this tutorial sheet. I'm sure tomorrow is the last day for math. Then those other coming days will be doing physics, I'm sure.
All right. I'm
Yeah.
not just sure about who sent the link, but I'll just like drop the tutorial sheet in each and every tutorial group that has been made.
Okay, that would be wonderful.
Right. And what time is math tomorrow, sir?
It should be 17 hours, if I'm not mistaken. All
Okay.
classes will be.
Can't you put it in the morning?
No.
No.
In the morning, it would actually be difficult because in the morning
Yeah.
you have to run errands. So we've actually set 17 hours to 18 hours. That's just an hour. So we've even taken 30 minutes of my time, you guys. But it's because I've actually enjoyed the company. I even want this meeting to be longer. So it's only 17 hours. Yes. Anything else? Hello.
Sorry, just a last question. So that means if a domain is mapped on two images, that is the range. Does it mean it's a domain or not?
Would you go again with your question?
Or like on question 13.
Okay. Yes.
Let's say if we have two domains going on the same range, is it a function or not?
It is actually not going to be considered a function because if you remember the definition for a function, it says it has to have a unique element in X being mapped onto Y, which has a unique element as well. So if you look at, I'm sure you may have had such an example if you used to attend classes. This is X, X squared. Let's say this is at 0. Just to draw this curve nicely. This is the graph of Y is equals to x squared. If this is y, and this will be our x-axis. If you look at this is not considered a function because
Okay.
we have one value of x giving us what? Two values of y. That value and that value. This can only be a function if we are dealing with just either the positive end of x or the negative end of x. That is when this can be considered a function. Otherwise, a function has to be considered in that way. Is it clear?
Yes, it is.
And is there anything else before I leave this meeting?
So that means but we can have two ranges on one domain.
Two values in the range on one domain. That is the same point I was just excluding from the same.
All right.
I'm sure we are good. I won't leave any of you with Chilaka to take poison if I leave, right?
Yes.
So, sir, I hope it's clear. I'm going to send the tutorial sheet.
Okay, no problem. As long as you send the tutorial sheet and it reaches me and I'll be the one taking you in the next class, then we'll cover the same tutorial sheet. That's not a problem. Because we've just tackled just part of the function. I haven't even touched the composite functions, how to get the inverse of a function. Those are the things we're going to cover next time.
All right.
But your name is Mr. Dingani.
Yes, you can just call me Dingani.
Oh, okay, sir. Sure.
Yeah, I actually don't take up this is too much.
Sorry, one last thought. Where are you found in school, sir?
Right now I am not found in school. Right now I'm just somewhere home in material.
Oh, okay, no problem.
Yeah, but I will be in school very soon.
Okay. So let's say we want to reach you. How do we reach you? Or maybe if you can just drop your line or something.
Okay, let me just try to text my line just here.
Okay.
Yeah, so the meeting will be ending. That's for texts or calls I can take on that line. Then if you want to reach me on WhatsApp.
Okay.
And please, when you contact me, make sure you introduce yourself in the text. Because I usually I will just get messages not knowing where they're coming from, and it doesn't come out right when I ask you who are you. Okay, I'm sure you've copied that number there. I'll be ending the meeting in about 2 minutes. Hope you guys enjoyed this tutorial session, and I hope next time we meet as well. I've enjoyed this group. The emoji guy is good.